Welcome. So you're wanting to learn how to use Unreal Engine to make video games. You've probably seen some of the amazing games that have been made using Unreal, so you know that if you want to make your own games in Unreal Engine, you need to learn how to use it. But what is Unreal Engine exactly? It's important to understand that question, at least at a basic level, before you get started diving into Unreal. So if I were to ask you right now, what is Unreal Engine? What would you say? You'd probably say something like, well, it's the software that was used to create video games like Fortnite. So we all have a basic understanding that Unreal Engine is used to make video games. But what does all of that entail? How do you make video games? Well, Unreal Engine is what we typically refer to as a game engine. Engine here is a pretty broad term that encompasses a lot of different capabilities packaged into one giant piece of software. More accurately, we'd call it a software framework, or a collection of multiple different components that all come together to give you the tools to develop your own software applications, or in our case, games. Now, all of that sounds very technical, so let's break it down at a very basic level. What are the different components that have to exist in a game engine to make it, well, a game engine? There are many different components that make up a game engine, and Unreal Engine in particular is adding new ones all the time. So we don't need to cover every single feature of the engine, but we'll just mention a few here. The most basic requirement for a game engine is perhaps the rendering system. This is the ability to generate an image on the screen. Now, there's a lot of technical details that go into this very basic requirement. When you play a video game, you're constantly looking at the screen, and that screen is continuously rendering an image, and usually that image is changing very rapidly to give you the feeling that things are moving in the game. Now, usually you're holding some sort of controller, or pressing buttons on a keyboard, moving a mouse, or pressing on a touchscreen while you're playing a game. These are all forms of input. A game engine needs a way to take that input and translate that into game actions, so game engines need some form of input system to handle that. Games usually generate sounds and play music while the game is running, so the game engine needs an audio system to handle all of that audio. When objects move around in a game, there's often a physics system that performs all of the calculations necessary to make objects fall, bounce, roll, and fly through the air. The physics system makes those calculations to determine the positions of objects in the game. Speaking of objects, the game engine needs a way to handle assets, 2D textures and images, 3D objects, which we refer to as meshes, sounds and music, animations. These are all assets that need to be imported into the game engine, and there needs to be a system to handle those files so they can be used in the game. Games almost always have buttons, progress bars, menus, and inventory systems, and these are all part of a game's UI, or user interface. There needs to be a way to create the UI for the game and link it up with the actions that those UI elements are supposed to affect. Now, all of these features are typically built into a game engine. It's not expected for a game developer to create their own physics system, for example. These are all part of the game engine package that game developers use when they're creating their games. So how does a game developer use those systems to create their own games? Well, a game engine typically has a scripting system designed for game developers to use. How do you make a football fly through the air? You don't need to calculate your own physics equations for projectile motion. Those are already built into the engine. You need to access those physics capabilities through the scripting system, a set of functions and routines that you can use to tell the physics system what to do. Now, this doesn't just pertain to physics. The scripting system allows game developers to access all of the systems necessary to create gameplay. Scripting allows game developers to access libraries of pre-written code to implement what we refer to as game logic. These scripting systems are typically some programming language, though Unreal Engine has blueprints, which are based more on visuals than lines of text. And for that reason, they're much more approachable and easier to learn than a text-based programming language. You're still scripting, but you're using a more user-friendly system to do it. Now, game engines encompass much more than this short list of features. For example, multiplayer games connect players from across the globe and allow them to play games with each other across the internet. So a networking system is needed to achieve multiplayer functionality, for example. When you see smoke and fire, sparks, electricity, and other special effects, those are handled by an effects system that generates what we call particles. These can really make a game pop. So just keep in mind that there's a lot under the hood of any game engine, and Unreal Engine is no exception. You don't have to master all of the components of the engine. In fact, Unreal Engine is such a vast system that you're rarely ever going to find a person who knows everything about every single system. Game developers often specialize in specific areas in game engines and master those areas so they can do their jobs well. But as you develop your own games, you're going to get exposure to many of the systems in Unreal, and it's going to be very exciting to see them come together to create your game experiences. So enough talking about game engines. We now have a basic understanding of some of the things that they contain. It's now time to open Unreal Engine and see some of those systems hands-on. So let's get started.